Hello everyone. The last topic of your second module is inverse transform technique. This inverse transform technique is used to sample the exponential distribution, uniform distribution, variable, triangular distribution functions. These are all some of the distribution functions which comes under inverse transform technique. Here first we should know the basic principle of your inverse function, that is inverse transform technique. Okay, we have to just find out the inverse function of f, that is inverse function of f. How will I just write the inverse function of f? I'll just write it as f inverse. Okay, so if I write like this, f into f inverse equal to f inverse into f, will just get it as 1 itself. Okay, 1 by f into f, 1 and f will get cancelled and this is 1. Okay, this is the standard principle of your inverse function. This f inverse denotes the solution of the equation. Here we'll just use the equation r is equals to f of x. We'll just define it in terms of r. The inverse function will be defined in terms of r. For example, if you have y is equals to x, then how will I just write the inverse of this? I'll just write the inverse of this as x is equals to y. But if I have y is equals to 2x plus 1, then how will I just write the inverse of this one? You have to solve for x. So I'll just take x is equals to y minus 1 divided by 2. This is the inverse function of this one. X is equals to y minus 1 divided by 2. If y is given, you have to solve for x. Here, see, x is here. You have to solve for this x. This is called as the inverse function. In this way, I have just told you so many distribution functions you can define by using inverse transform technique. First, I'll go for the exponential distribution. Yes, exponential distribution, already you know, we'll just do this with respect to the mean. See, this is CDF, that is the continuous distribution function f of x will be given as the summation I is minus infinity to x f of t distribution function, that is 1 minus e power minus lambda x, where x is greater than or equal to 0. If x is less than 0, then we'll consider it as 0. This is the standard exponential distribution function we have for f of x. Now we need to solve for y. Yes, that is y is equals to 1 minus e power minus lambda x for x, where y is uniformly distributed over the interval 0, 1. Okay, let me see what is the procedure to solve this exponential distribution. See, exponential distribution, the very first step, you have to compute the continuous distribution function, that is CDF of the desired random variable x. Here also random number will be given, and for the random variable you are solving this one. So you know the function, that is f of x is equals to, we know the distribution, exponential distribution, that is 1 minus e power minus lambda x. Okay, after this one, next step 2, you have to just assign it as r is equals to f of x. In the beginning I have just told you, you have to define it with respect to r. So in step 2, I am defining it with respect to r. R is equals to f of x. Already we know f of x. So r is equals to 1 minus e power minus lambda x, where x is greater than or equal to 0. Next, step 3, we have to solve for the equation f of x is equals to r for x in terms of r. So for that, what you have to do is, see, 1 minus e power minus lambda x is equals to r. We have already have this one. I have just told you, you have to solve either for x or y. Here x is there, you have to solve for x. Thus I'll just take this r this side, e power minus lambda x is equals to 1 minus r, then x is equals to this one. I'm taking a logarithmic function, minus 1 divided by lambda ln of 1 minus r. This can be written as x is equals to f inverse of r. Okay, I'm just solving for x. F of x is equals to r means I'm taking x inverse is equals to, x is equals to f inverse of r. Okay, and the final last step is your formula. That is, you have to just generate the uniform numbers. From these uniform random numbers, you have to compute the random variate. To compute the random variate, this is the standard formula we have, that is xi is equals to minus 1 divided by lambda ln of 1 minus ri, where I is equals to your 1, 2, 3 till n. These are the random numbers r1, r2, r3 till rn. Now let me go for the problem. See here, lead time have been exponentially distributed with mean 3.7 days. Generate lead time variate from this distribution using inverse transform technique. These are the random numbers which are given. Here they have given mean is 3.7 days. Okay, here mean, we consider x bar as mean actually. Yes, x bar as mean, and this x bar will be, that is x inverse, will be considered as 1 divided by lambda. So mean is equals to 1 by lambda. Therefore 1 by lambda is equals to 3.7. It is given mean. Okay, now you have to find out the random variates. Here 5 random numbers are given, means you have to find out 5 different random variables. So first I'll come to this one. X1 is equals to what? Minus 1 by lambda. 1 by lambda is given as 3.7. So minus 3.7 ln of 1 minus r1. R1 is 0.01. The value will get it as 0.3718. In the same way, x2, R2 is 0.13. This is the x2 value. Then x3, you have to put R3. Then this is x3. Then x4 and then x5. So you have to just write the lead time variates are these 5 what you have generated. This is your exponential distribution function. Here you have to just remember the formula, minus 1 divided by lambda ln of 1 minus ri, and 1 by lambda is always the mean. Okay, as next method we'll just go for your uniform distribution method. This is one method we have studied, that is exponential distribution. Next we'll go for uniform distribution. This uniform distribution is, in the name itself it is there. It is used to generate the uniform random variables which is continuous. Uniform distribution means it should be continuous over a comma b. This is the interval a and b. In between a and b it will be continuously distributed. Okay, here first you have to just find the continuous distribution function f of x. It is given by x minus a divided by b minus a, and for all the things it is r is equals to f of x. In inverse transform function, each and everything you have to just what? Denote it with respect to r, that is r is equals to f of x. F of x is given, we have already known. So in place of f of x, I'll write x minus a divided by b minus a is equals to r. Then what you have to get? This is the inverse function. X is equals to f inverse of r you have to get. Okay, so we know the value x minus a divided by b minus a is equals to r. Now you have to solve for what? X. I'll take this b minus a here. X minus a is equals to r into b minus a. Then x is equals to a plus r into b minus a. This is your standard uniform distribution formula. By using this one, you have to just generate the random variates, generate random numbers and find the corresponding random variates x1, x2 using this function. Now this is also very easy. We'll go for the problem. Generate 5 random variates which are uniformly distributed in the interval 3, 5. 3, 5 means interval they have given. This is a and this is b. Okay, these are the random numbers which are given. A is equals to 3 and b is equals to 5. By using this formula, you have to just generate the random variate. That is xi is equals to a plus ri into b minus a. You have to just take x1 is equals to a value is 3 plus r1 value. R1 value is 0.779 into 5 minus 3. So this is x1. In the same way, x2, x3, x4 and x5. These x1 till x5 are the random variables which are uniformly distributed over 3, 5 interval. This is uniform distribution. In the same way, you have a procedure for triangular distribution, Weibull distribution, and then your continuous discrete distribution, empirical distribution. All these things I have already provided means all these things you have a procedures. In the same way you have to just do all these things. Fine. Thank you.